way.
Okay.
You can share your screens.
Um, all right. So good morning, everyone. I'm Alankrit, and my team consists of Divyanshi, Ishan, and Subir, and all of us are engineers from India. Um, Today we'll be talking about our project idea, which we call LabExp. So moving on, let's just dive into the problem statement here. Uh, we did some Fermi problems related to the problem statement that we were trying to tackle. And we were trying to understand how much expenditure does the government intake in India on every student. And that turns out to be about $50 per student per year. And this includes everything from books, teacher salaries, infrastructure, syllabus curriculum, and lab infrastructure. And this turns out to be a really small number if you compare to the scale of the problem that we are dealing with. So today we'll be focusing on the lab infrastructure problem. Given the large population, given the large number of students and the low resources that are being spent on lab infrastructure, there is a lot of burden on lab experiments. But just to give you in context, we are talking about India, and in India, how like lab experiments are done in school is that kids fill up a lab space and then they try to perform experiments, but these experiments are less in number. So multiple students end up doing one specific experiment at the same time, or the teacher ends up explaining the experiment to these students. So in this way, the students don't really learn a lot, and they go away with very partial knowledge. So this is the problem that we are tackling today, which is burden on lab experiments. The second problem statement that we are trying to tackle is how do you perform experiments, school experiments, outside of your school environment? How do you perform it at home? How do you perform it before an exam, which is very crucial for students to really revise certain concepts? So this is the problem statement that we are trying to tackle. Let's get into what some of the competitors or some of the people have tried to, how have people tried to solve this problem. And I'll start with the bottom left here. The image on the bottom left is from an initiative by the government of India called Atal Tinkering Labs. So Atal Tinkering Labs is a sort of mobile labs that has been set up across India in multiple districts, where they teach students practical concepts like robotics, drone technology, etc. But as you might understand, this is a different problem than what we are trying to actually solve. We are trying to solve the problem of school curriculum experiments, but Atal Tinkering Lab focuses on some high-tech experiments that are, that might be away from school curriculum. We also found certain companies coming up with kits like what we are proposing. So something like Box of Science, which is chemistry-related equipment. Again, these are boxes of activity experiments and not really tied to school experiments. And these are expensive. And the target audience for our case is our government school students. So these really do not impact the people that we are trying to solve. Another initiative that we found was interesting was the video on top. This is developed by Amrita University, and this is from the Ministry of Electronics and Information Technology, where they have simulations of each experiments from curriculum. So if you look at this, they have actually this pendulum experiment, so that you can actually change the pendulum length, you can change the diameter, and you can sort of simulate the problem. This is great, but we are trying to solve it in a different way, which is we want students to do it by their own hands by using frugal concepts. So I'm introducing LabExp here, and this is a mock-up which I created from an AI platform. This is not real, but this is just how, we just got a board like, a kit using using AI software. So let's dive into what our approach is. We are focusing on CBSE class 11th physics curriculum. What we are proposing is that we will have assemblable kits with some elements provided, while we encourage kids to find other elements from their experiments at their home itself. And to do a specific experiment, we want to tackle it in an accurate way and in a frugal way. So we propose two routes to do the same experiment. So essentially, our goal is to make school science experiments accessible and fun by using components found from home and in the kit that we are trying to provide. So some of the essential features of our kit would be, the first one would be a base kit. The base kit has been inspired from a Foldscope accessories kit, which I have just right here. It has multiple components which are relevant to a lot of experiments. So this kit would be just a base, and it would have elements such as a weight slot, a stopwatch, batteries, LEDs, which students would require for all the experiments. And then would be a kit for a specific experiment. And the kit, so like I've said in my previous slide, there would be two ways to do an experiment. We'll be proposing two ways. The first one would be an accurate way, where the kit would contain elements to carry out the experiment in an accurate way. And then we will provide suggestions for frugal alternatives for these elements for the accurate way. And then we'll have a lab manual. So these are the essential components of our design. But let's move into certain specific experiments that my team has been working on and how have we designed them. So Divyanshi, take it from here.
All right, thank you. So first experiment which we picked up was to determine the coefficient of friction, limiting friction, using that block and pulley method. So for this, we all know what is the accurate way. We need weight box, we need pulley, we need a weight, we need proper common balance, etc. However, to do this frugally, we came up with certain alternatives. For example, instead of weight box, we picked up coins. 1 rupee coin, 2 rupee coin, 5 rupee coin. And the reason of choosing coins is their weight is fixed. And hence, by doing simple mathematical calculation, we can find how much weight is there in the pan, which is going to weigh. Again, the question comes on the place where we are going to place the weights. So this is a very simple and very creative thing. We use the diya, normal earthen lamp, in which we will keep the coins. Again, another constraint in front of us was to design the pulley. So for pulley, what we did was we used this reel on which we tie thread, sewing thread. And what we did was we attached it to a pen, used another pen cap, and then used some crocodile pins. And then simply attached it to the table using sellotape. And later, however, yes, some friction was there, but if we will oil it properly using mustard oil and all, it was able to work as a pulley. And for weight, we can use any normal weight. I used an old cell phone over here. And Alankit, you can play the video. I mean, yeah, the experiment is indeed working. And here I was adding the coins. 1 rupee coin, 2 rupee coin. And then, yes, if it moves very fast, we can remove this coin and we can add even those. I mean, in ancient times, we used to have those chabanni, 25 paisa coin. I was having them, so I thought I can use even those coins as well.
So this is the power of experiments sometimes, that we all know it's a video, it's going to work, but we are still waiting to see what happens.
Right.
Yeah, right. So yes, that's how it happened. And to an extent, we were successful. There were certain problems associated. For example, pulley was not totally frictionless. Again, problems like coins, at times it moves very fast, and hence we don't have the exact value where that exact little bit sliding will happen. So yes, we are still working on it. However, yes, to an extent, it was very frugal to do this experiment to understand how it works. Okay, thank you.
Thanks, Divyanshi. Ishan?
Okay, so my experiment was that simple pendulum, which we have done in 11th and 10th class. So for this experiment, we need the whole pendulum setup. So for that whole pendulum setup, we used bamboo sticks and some crocodile clips. And for that bob of the pendulum, we could use grapes or a marble or any small heavy object could be used. So this is the complete bamboo thread and sellotape pendulum. So like it is completely, and best part of this is that it is completely biodegradable and it is working properly. And my idea here is that the main problem from our kit was that after a certain time, the kit would be useless for everyone. Like in 11th class, we have done the experiment. Now it is useless. So what to do with the kit? So I came up with an idea, not an idea, just copied from somewhere else. So we have seen that sapling pencils that came, that after using the pencil, just plant it inside the soil and just water it and we have a plant. So just making our kits biodegradable and adding some seeds and covering with a cellulose covering. After the use, they can be just put inside the soil and we can have a plant of it, like completely eco-friendly kit. And there were few inaccuracies during the experiments, and that could be rectified after a few more tries. So that was it.
Okay, great. So these are two experiments that we, really did in person. And the thing that I was focusing on was another experiment, which is finding the focal length of a concave lens. And for this experiment, this is different from the other one because for lens, it's just difficult to find a frugal alternative. For this particular experiment, what we are proposing we'll just give students certain lenses that they'll be able to do experiments with. And the other devices such as an LED, the light source would be available in the base kit. So something like this. So this is just a box of lens that are of different shapes, concave lens, convex lenses, and these can be used in the experiment. So we do not have a lot of time, but I'll dive into the risks. The biggest one that we see here is that one of the experiments could be frugal for a person but not for somebody else. How do you create consistency? How do you create repeatability? Like the Divyanshi said, she was having problems with weight. She was having problems with just sliding of her weight that she was using. So how do you ensure that people use frugal alternatives yet they are repeatable? The experiments are repeatable and accurate. Another problem is supervision. How would you want kids to do electricity experiments with supervision? So that's something else we have to tackle. And of course, the scalability is another issue. We'll conclude here, but I'll just go. We have some takeaways. School experiments in India are really inaccessible outside of school curriculum. What we are proposing is a DIY assemblable fun kit, which is mapped to school curriculums made from frugal elements found from home, and also some elements that we provide. We have a base kit, then we have a lab kit that would have material for specific experiments. And this is the idea that we've been working on. And some of the future goals would be refining our design parameters for the accurate and frugal way, creating a prototype for the other experiments, expanding to other experiments, and obviously dealing with the cost constraints. Sorry, we went a little over time, but this is our team. Thank you so much, guys.
That's fantastic. Alankrit, if you unshare your screen, let's just do a couple minutes of discussions. Just a few comments. I mean, first of all, I love the focus. I think choosing physics experiments narrows it down to say you're actually tackling a real problem. So I think it's the focus part is very critical. And again, even in this context, it's broad. As the next round, it can even become narrower. For example, like you could only focus on mechanics or optics as a test case. The other thread, the balance between do something quickly, inaccurately with what you find, but then there is also some gold standard. It teaches people the idea of repeatability, teaches people the idea of where does accuracy come from. Mm-hmm. So it's far more interesting if I'm learning about friction to find that the pulley I'm using is causing a problem because that's the reality of engineering and science in general. So I mean, that pairing is just absolutely fantastic because often enough, we have this, I call this as a term of the onion peel problem. In microscopy, everybody has an expectation of what you would see when you make an onion peel slide, and you actually see what you expect, and it's done. There's no thinking. Mm-hmm. So embracing that in a manner and turning that into actually a design principle is just absolutely fantastic. So it's not a constraint. In some sense, people have to then identify in their own implementation, where did the inaccuracy come from? Mm-hmm. And in doing so, they have actually learned the principle far better. Right. Comments, people from the class, any other questions, anybody that's online? Maybe we'll have time for just one question, and then I want to move to next group. This is open mic. It's very valuable to just share feedback or even just share your excitement on something, because then you can come back and connect with the class. Okay, any questions? I'll give you guys a minute to think.
So while people are thinking, I guess we'll take this project forward as well. All of us on this are on the same page, and we want to work because this is not just limited to, just this class. I mean, it's a problem that students and kids face every day. So we're just looking for avenues where we can expand it, where we can first, obviously, we'll work on it, and then we'll search for avenues where we can try to push this.
Yeah, and I think, there's lots of partners and organizations to be thought about in terms of testing. But the big next step in my mind is, so I'll share with you guys an experiment that I've been designing for a while. It's been almost a year and a half now. I feel embarrassed. It's been such a long time, but I've been thinking about it for a very long time. But now I finally am implementing it. It's, in a high school with found materials, measure the size of the atom. And, but you have to come up with a number, right? And so I think the big thing that I would also suggest as a next step is bring numerics and numeracy into the experiments. Numbers should be popping out all the time, as quickly as possible, because it sort of gives people a sense of working with numbers and trusting numbers. Right. And so I think, we'll chat more when we kind of do the next round of discussion.
Yeah,
okay, I want to move to Paola.